This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. Our fearless host, Alan Hall, is back with us today, so excited to have him here. And in today's episode, we got a pretty wide-ranging topic. Obviously, one of the big ones that we'll cover at the end is what happened in Texas, right? Really big news. Wind turbines very much in the spotlight. But before we get there, we're going to talk about Iberdrola potentially building a pretty big floating wind farm off of the coast of Spain. South Korea on track to build the world's biggest offshore wind farm. Vestas investing in some wood tower technology. We'll also talk about down conductors. There's been some issues with some breakages we've kind of been peeking at on LinkedIn. And we'll also talk about a couple composite upgrades to both blades and nacelles. And lastly, we'll circle back to the Texas power nightmare that really took over the country took over the press cycle in the U.S. recently. So, Alan, welcome back. Glad to have you back on the show, first and foremost.
Yeah, good to be back.
So let's start with Iberdrola. So obviously floating wind, we talked about that a bunch. It's starting to pick up speed, right? There's more and more of these popping up. And that's a good thing long term because now they're going to be able to, hey, we've got more data, more of these out there bobbing in the ocean like cauliflower, right? And so some, see how well they work because they're obviously seems like pretty well proven, but not nearly as proven as other means of offshore wind.
Right. The offshore part is interesting in the sense that we're not really limited on the size of turbines, right? So the growth of wind turbines in terms of output size going into the 20 megawatt plus is going to happen offshore. And the capability to have literally gigawatts of power generated offshore is really, we're right on the precipice of that. So there's so much technology and energy being pumped into offshore wind right now. And that's where the growth is going to occur in that offshore wind sector. We're going to see a lot of great engineering changes and engineering improvements and just attacking a problem, which is really difficult, which is as these turbines get bigger and bigger and bigger, how are you going to handle all the loads? How are you going to be able to distribute the amount of energy coming off them? What do the failure modes look like? How are you going to be able to service them? There's a lot of engineering problems that come along with it. So it will be, the next 2 to 3 years is going to be really exciting in terms of the growth of the wind turbine industry.
Yeah, so this is these 300 megawatts of power, which is going to come with an investment over €1 billion, is spearheading what the company says will be up to 2,000 megawatts in new developments off the Spanish coast. So this is just the tip of their, well, should you say tip of the iceberg when we're talking about water? I don't know. It's the tip of the crest of the wave here. But yeah, and of course in bigger wind farm news, South Korea is planning the world's largest offshore wind farm, gigantic, $43 billion plan to put 8.2 gigawatts. So, I mean, just gigantic, off the coast of Sainan, a small archipelago west of Mokpo. So, if you're familiar with Mokpo, know what this will be. But anyway, they estimate it'll create 120,000 jobs, and they want to be one of the offshore powerhouses by 2030. So, anything stick out to this, or stick out about this as unusual, or what are your thoughts here?
Well, it seems like, is it more of a industrial growth situation? That's what it seems like. They're investing in local companies to develop wind in the hopes that they have an export market, I would assume. Because if the growth market is going to happen in offshore wind, which it will, then being a large manufacturer, having all the production in place to handle it, and because Korea is a big shipping export place. They make a lot of ships there, first off. So they know a lot about transporting of large objects around because they make the ships to do it in South Korea. So does it make sense for them to make the offshore wind turbines and to also bring them to where they need to go because they're also making the ships that do it? So the infrastructure, a lot of the infrastructure for offshore wind is already in South Korea.
Yeah.
It wouldn't surprise me. 100,000 jobs seems like it's probably on the small end of what that industry could create for South Korea.
Yeah. It is. So I mean, you mentioned the local companies. So it sounds like they're planning on putting Doosan's offshore turbines, which Doosan's obviously a South Korean company, but their biggest one right now is 5.5 megawatts, which is getting on the small side for offshore wind turbines, right? Obviously, who knows what their design is and why that's the right choice. But when you start to hear of all these, 14, 15 megawatt ones by, GE and Siemens Gamesa and now Vestas with their new 15 megawatt version, you wonder why you'd go 5.5 megawatts when you could easily go, 8, 10, and more. But again, I don't know the economics, and, I'm sure there's a lot of,
It's a growth thing. I think it's a growth issue where you start out smaller or moderately sized, and you work your way up to the bigger turbines. The only way to do that is to do it, right? Is to build that infrastructure one piece at a time. So they're probably starting off on things they can do today, knowing 5 years from now they're going to be a player, but they got to pump billions of dollars into that industrial system to get there.
Yeah. So moving on, Vestas is investing in Modvion, which is a company that's creating technology for wooden towers. We talked about this in the summer. In April, they installed a 30-meter tower on an island in Sweden, and their goal is to complete their first commercial tower in 2022. So this is obviously like a big carbon footprint kind of thing. Is that right?
Yeah, right. Resources, sure. Sure. And recyclability, I assume. But it also may be a way, like we talked, or we're going to have coming up on 3D printed concrete towers. It maybe just another way to do it, depending on where the location is and how you want to build them, right? Could be.
Yeah. Well, and we've, in our upcoming episode, we're going to talk with Henrik Lund Nielsen from Kobod, where they're talking about 3D printing wind turbine bases and potentially towers as well. So the idea of using non-steel materials for wind turbine towers in the near future is, it's a couple different options coming up pretty quick. So pretty interesting.
It's going to happen. Don't you think that's going to happen? We're going to make the transition away from steel eventually, or at least in some applications, you're going to move away from steel. And concrete would be one of those answers. Like that is for certain. And the wood may play out too. Right? There's having more options is always a better situation for everybody because, transportation of the towers and all the infrastructure that has to happen around those towers, those steel towers, you're kind of getting to the limit of being able to move things, right? And you're going to have to do it in sections pretty soon. That's why the concrete makes sense and why wood in sections starts to make sense.
Yeah, absolutely. So more on the composites kind of side, the natural fibers kind of side. So let's talk about Green Boats. So they're a really interesting company. They make some, beautiful boats. They're a German company, and they've been touting a offshore nacelle project recently, which is pretty cool. Obviously, nacelles typically have a fiberglass, top to them, like a steel frame, but a large chunk of it is composite, and their goal, Green Boats uses like natural fibers in their composite mixes and all that stuff. So their goal is to make green composites in this nacelle. So, what problem do you see that solving, Alan?
I think it's a recycling problem, right? From the fiberglass epoxy nacelles that are typically used today, what do you do with them when you decommission a turbine? Do you grind it up and make it into some other object, or you bury it? What do you do with it? Having a material that is quasi-biodegradable, right? So if they're using flax fiber as the fiber instead of fiberglass, that's a natural product. It's grown, right? So it's just a harvested product. And we've been using that. We've been using flax for all kinds of industrial products for hundreds of years. So I think it makes sense. And the nacelle is probably the right place for it because it's not a critically loaded structure. There's not a lot of, this isn't like a blade where it has a lot of load onto it. It's basically just a shell, kind of somewhat to a boat, honestly. So it's the right application that's the hardest part, is finding the right application for the right technology. And it seems like they're pushing in the right place. So it'll be interesting to see how it plays out, because at some point it's going to be a cost-driven effort. If the costs are the same for Greenboat to make a nacelle versus a standard fiberglass epoxy company to make it, they may get chosen more just because the recyclability is going to be a plus in their direction. So we'll see how it plays out, because there hasn't been a lot of recyclable materials in wind turbines. Have you noticed? Everybody's really making a push to make them more recyclable, because so many are starting to come out of service, and yet they're not recyclable.
Yeah,
for the most part. Right?
Yep, the world is quickly filling up with trash. I mean, it's certainly not funny, but that's definitely what's happening. I mean, I think everyone's becoming more aware of their own plastic use and all this stuff. And like you said, the bill's coming due a little bit with a lot of these wind turbines coming out of service. So ending up in those big blades ending up in landfills is crazy, and obviously nacelles are part of it too. So last thing in this segment, let's talk about this interesting Evo flap, which is a root aerodynamic flap. Evo flap, or Evo Blade is the company out of Germany, and Evo flap, it looks like it's going to increase some of the aerodynamic flow, but is also potentially a pretty large, a large performance upgrade to be added to a blade as a retrofit. Right. So, I mean, we've talked to others on the show about aerodynamics. I mean, where are the limits of tampering with? I shouldn't say tampering, but with upgrading or adding to blades that may not have been tested for that use or for that upgrade in the factory?
Well, it's a really good question, because any alteration to a large structure such as a wind turbine blade is always fraught with the danger of, do you put some damage or put some load on the blade in which it was not designed for, and then over its service life you end this fatigue factor? Does it end up damaging the blade larger structurally over time? That's a really good question. Increasing power production is a real need. It obviously is. There's a lot of companies that are adding power curve upgrades to wind turbines. So the question is, do you know enough about the blade itself to make that alteration? In most cases, you don't, because the blade manufacturer is not the company that's putting on the upgrade. So there's some assumptions being made about what that blade can handle and how much load you're putting on that blade to get the power curve improvement. So the use of basically flaps or spoilers is a viable means to increase power production, no doubt. I think it just comes with the added engineering assessment that has to be made, which is, if I add on this aerodynamic change, does it increase loading on my blade? Do I have to worry about it going forward? Do I have any service history with my particular blade and my particular design that I'm not going to do some unknown amount of damage going forward? That's the cost benefit analysis that has to happen. Mm-hmm. Power curve improvement, risk of blade damage, what does that look like? And a lot of times you don't really see those numbers. That's the hard part, Dan, is that those numbers are not provided on the websites, that's for sure. So whether they're provided to the operators, I don't know. That's a good question.
Yeah. Well, like you said, I think it just warrants more cost-benefit analysis, where someone needs to determine, is this going to be right for our model of turbine, and how do we know, and how can we know? Like, what else can we do to figure it out? And, we can see that the benefit's there, but is it going to be right for our application? So, yeah.
Yeah, right.
All right, so let's talk a little bit about down conductors. So we both follow Blade Partners on LinkedIn. They often post a lot of really interesting photos of their repairs done up tower, and they seem to do really, really great work. So some interesting photos about snapped down conductors, which is obviously a major lightning issue. And then there's just lots of other just blade damage in addition to the down conductor. So, we really encourage you to go follow Blade Partners on their LinkedIn page. But Alan, how do down conductors snap? Those are pretty thick, pretty robust cables. How does that happen? I mean, isn't the lightning supposed to just hit the receptor, flow through it, and go about its business?
Yeah. Well, there's a couple of different ways you have a broken down conductor. Some down conductors are actually built in segments that are fastened together down the length of the blade. So you can have because of the flexing of the blade, you're flexing these joints, and the joints fail. So you have actually a physical break in the down conductor, which is a problem. The other way they break is they're really too tight in the structure, so they're getting fatigue, pulled and compressed, and eventually they snap. The other way we've seen them break is the lightning protection system on the blade isn't too functional. Usually lightning protection systems tend to degrade over time. So you get into years 5 through 10, 5 through 15, the lightning protection system at the tip isn't all that great. And the lightning starts to reach out to other places like the down conductor, and it'll hit the down conductor and weaken it or separate it, just physically break it. Because the down conductor is meant to carry lightning energy, not to take a direct attachment of lightning to it. Because a direct attachment has a lot of heat. If you can well imagine, it's like an arc welder hitting a cable. If you hit a down conductor cable with an arc welder, you're going to cut into it. You're going to actually physically make it weaker. Right. So you've now changed the stresses in the cable, the flexing of the cable eventually in breaking. That's what will tend to happen. So there are a number of ways to break that cable. The critical thing is, and this is where Arones over in Latvia is trying to do measurements on all these wind turbines to measure if the down conductor is really there or not, and what the resistance of those down conductors are. That's really important, because if you do have a breakage of a down conductor in the blade itself, you can't see it. There's really no way to know that without taking resistance measurements. And if you do get an open circuit, basically a very high resistance measurement from the blade tip to the turbine nacelle, something is wrong inside that blade, and you better fix it now, because if there is a broken down conductor inside and you do have a lightning strike event, it's going to be all kinds of arcing and sparking inside that blade that you just don't want, because it's going to do real structural damage to the blade. So it's a pretty serious issue. And Blade Partners does put a number of magnificent photos on their website, and they do talk to some of the issues that they see around the world. And I think it really does a service to the wind turbine industry to know these are the sort of failure points that we're having out in the field, because that's only the way engineers can correct those situations, is to have data, have some real data. And Blade Partners does a good job of highlighting those issue areas.
Yeah, that's interesting. I hadn't thought about that, because I used to weld a good amount in high school and into early college. I worked on cars and really enjoyed metal work. But yeah, when you're welding, obviously the arc is melting, it's creating the weld, but then all that same electricity is going to flow back through the piece and then into your clamp back into the machine, and those parts of it are completely unaffected. So yeah, that analogy immediately clicked with me, where that makes perfect sense, where if it directly strikes the cable, it's going to act like a welder, like you said, and damage it, put a lot of heat right there, but then it's going to flow and go back where it needs to go, which is going to be into the earth, obviously. So yeah, okay, interesting.
Right.
But yeah, it's crazy to see those big cables snap. I mean, you think of things at a certain thickness, you feel like that could never break, right? But they can.
It shouldn't. Yeah. Right. It shouldn't break, and they're designed not to break, but there's other effects happening on that blade that have caused that cable to snap or to be hit by lightning, which is probably the worst case situation. Yeah.
And then fixing that, I mean, they're just going to replace the down conductor. I mean, is that the only fix? I mean, what's the action item?
They'll splice in a new section typically. So you can, if you think about wiring a car, you can put a splice into a set of wires to make the wire longer. And so there are mechanical splices that do a pretty good job of carrying lightning current. There's different varieties of them, but essentially they're mostly some sort of compression fitting that takes the good part of the copper down conductor to the good part of the good copper down conductor and adds that splice. So you have to have the proper tooling to crimp those connections on. Rarely do they weld them. Have heard of people trying to weld those together, or solder, quote unquote, solder them together. There are means to do that, but it really does not work in a wind turbine situation. You're going to have some sort of clamp, compressed fitting that puts a new section of down conductor in for the damaged section. So it's involved. I mean, obviously, you're probably going to do it by cutting open the section of the blade to get down to that down conductor. And once you're into the down conductor, then you're going to have to expose it, clamp it, seal it all back up, and try to rebuild the blade from the inside out, which is going to take some time. Really will take some time.
All right, so let's transition here to Texas. Man, what a story in the last couple weeks. Obviously, really a rough situation. A lot of people were out of power for a long period of time. A lot of people died. Just an awful situation in general. I mean, President Biden declared a disaster, and rightfully so. And of course, the question is, there's a lot of finger pointing, and also rightfully so. But the question is, why did this happen, and which of our main power sources failed? And there's been a lot of fingers pointed at wind, which deserves, wind deserves one of the fingers pointed at it, just like every other power source,
Sure.
And maybe the people behind it. But, wind power was a much smaller percentage of Texas's total grid. The natural gas and coal are by far the bigger contributors to the Texas power grid. So, and what's interesting, and one of the things I want your opinion on is, so Texas gets 46% of their electricity from natural gas, says up to 23% in wind, 18% from coal, 11% nuclear, 2% solar. That's according to ERCOT, and a cool diagram by Joshua D. Rhodes shared on Newsweek. But, on some news sites, it's, and let me read a quote here by Sid Miller, who is Texas's Commissioner of Agriculture. So I'm not sure what his real relation is, his knowledgeable, how knowledgeable he is about power. But he said, "We should never build another wind turbine in Texas. The experiment failed big time." So, I mean, by that logic, does he mean we should never build another coal plant or another natural gas plant because they equally failed? It's interesting that wind gets the finger pointed at it. When really all of it's to blame. But I mean, Alan, what was your take of this situation?
I think right now it's what I would call the fog of war. It's too early to tell what the real pinch points were and to have any real discussion of what to do about it. First off, you're talking about a once in 50 year kind of event, once every 100 year kind of event. And does it make sense to modernize a system or winterize a system so they can handle that 1 in 50 year event? Maybe it does. Maybe it does. But to point to one particular energy source as being the main contributor, I think, is never the case, right? In any sort of large power system distribution failure, it's usually a combination of sources. There's many variables that go along with it. And to pick one out sort of misses the whole point of the problem, right? The real problem is it got really cold in Texas for an extended period of time. A lot of equipment's not winterized. I'm sure. Why would you do it? Because it rarely happens, right? And a lot of other things happened. It was sort of not so much calamity of errors, but just sort of the way the system was designed. That was going to be the outcome, regardless of what the power sources were, because pretty much every power source had an issue because it's not designed to handle those cold temperatures for that long a period of time. So I think it does everybody a disservice to pick out one so soon without having the facts. Because what are you going to do? Really, what are you going to do? You got so many wind turbines in Texas right now. You're going to turn them all off? No, because it is providing a substantial amount of the power for Texas. You can't do that. Do you want to winterize them all and basically put anti-icing or de-icing features on all of them? No. That's going to be super expensive. Do you want to plan for that 50-year event? That's a better discussion. Do you want to plan for that 50-year event? Maybe you do. And what does that look like? Is it $1 million? Is it $100 million? Is it $1 billion to do that? Yeah, and that's where the rubber meets the road in terms of engineering. Is there's a cost benefit to everything that you do. Yeah, could you winterize everything in Texas? Absolutely, but there's only a limited amount of funds to do it with. Mm-hmm. Do you have the funds to do it, or can you use those funds to do other things that need to get done? Yeah, you got to weigh those off, and someone's got to make a decision. And I always feel like a 6-month downtime on something like this is probably the right answer. That you need to get the engineers involved and get people really looking at it closely to see what can be done relatively shortly and what needs to be done more of a long term. Because if it is, let's just say you had a frozen pipe somewhere. If that one frozen pipe knocked off 100,000 electricity users, then fix the pipe. Put a heater on the pipe. If you're talking about fixing all the wind turbine blades in West Texas, that's a bigger problem. That it's going to be more costly and may not make sense to do.
Yeah.
Don't you think we're still there right now? It's too
Yeah.
early.
Well, and this to me is just it's a black swan event, right?
Mm,
That's Nassim Nicholas Taleb. I've mentioned him numerous times. I've found his books really interesting. They're on my reading list for 2020. And he talks about
yeah,
these big events because it deals with
yeah,
forecasting and on Wall Street. And the great example here is the COVID-19 pandemic. Could anyone have predicted that this would have happened? And why wouldn't some of these big businesses have kept more cash so they could withstand a pandemic, right? Well, who would have anticipated it? Should we have learned a lesson from the pandemic back in like 1920? And this is the same exact thing. Like they hadn't had a storm like this in Texas in
yeah,
50 years or more. I can't remember the exact
right,
number,
yeah, yeah,
but a huge amount of time. And so it's not clear that you should always plan for black swan events. Maybe in some cases you just need to absorb them and say, look, we know that if this kind of crazy storm, which happens on average once every 50 years, it's going to hurt us X amount. You might plan for it financially in some way, but I don't know that you're going to,
sure,
just like say there's a flood every 100 years that's going to reach up somewhere where it's just like it never floods. Do you get flood insurance for your home? I don't know. If you would live in Louisiana, do you get flood insurance for your home? Most certainly you probably do, right? Especially if you're in New Orleans.
sure,
But like I don't know that you get flood insurance if you live in Tennessee, even though maybe there's a crazy
right,
one. I don't know. It comes back to that where it's not clear yet whether it would have financially made sense because the big finger pointing is, well, these wind turbines they're just junk and they turn off right when you need them. Well, they just didn't install the winterization packages. Like they don't have blade heating elements to keep ice off the blades because why would they?
sure,
Right? Like it's not clear that they would need that. And then they didn't get these other packages. There's other winterization stuff that you can get in a wind turbine, different types of oils and all sorts of things that are going to
sure,
keep them.
yeah,
I mean, these things operate in Minnesota just fine, in Finland, and
right,
in the Arctic almost, right? They operate in
right,
brutal
yeah, they
conditions.
do.
But in Texas, they're like, we don't really probably need that except once every 50 years or 100 years or whatever. So yeah,
That's right.
so people think the wind turbines are just unreliable, which is not true. They just didn't really buy the right package for it. So
Well, and it comes down to cost of electricity, right? That if let's just say they decided to winterize all the thousands of turbines that sit in West Texas, that's going to be a larger energy bill.
mhm.
That's where that cost gets distributed to. It ends up in the cost of electricity. So I think if you would ask the common consumer, would you want cheaper energy over a 50-year period for that one event? You could live through that 3-day event. What would you do? And they're going to choose cheap energy over the 50-year period every single time. And that's what engineers and sort of the financial people do every day is try to put risks and what the cost of those risks are and try to weigh them off versus the cost of making it an improvement. That's what they're doing. And so the risks were relatively minor compared to the cost. I'm sure that they were. That's why they don't have the winterization systems in the turbines. Much like they
Yeah.
don't have winterizations in the natural gas plants. Same reason. Doesn't happen that often.
Yeah, and it's easy to look back now and say, "Oh, you clearly should have done this. It costs us so much and lives and all this." But if the storm hadn't happened, there'd be a lot of wind farm operators looking out the window at the extra millions and millions of dollars they spent on winterization, wondering why did we do
Right.
that? Like it's been 20 years
Right.
now. We've never had any use for any of this stuff that costs us
Never
millions
once.
of dollars. That's easily on the other side of it. Just like with 9/11 was a huge black swan event.
Oh, huge.
Like, should we have
Sure.
been having incredible security measures to prevent something that we had no idea was going to happen, something that was kind of unthinkable? I mean, there was no conceivable
Great question.
need for
Yeah,
that security
right.
prior to that happening, which is terribly unfortunate. It was an
Right.
awful event. And now
Yeah.
security's been much higher after we knew that something like that could happen, which, is awful, terrible day
Right.
for America. So, with this, it's just like, well, there's probably not going to be another storm like that for another multiple decades in Texas. So it's not clear that we
Right.
should rush and change this, and that with every, again, black swan event like this, that you should quickly. But like you said, I think you brought up a good point, which is that there's probably other things that are easier. Like a lot of the natural gas failed because things froze. And so like you start to weigh the cost. Well, we don't need to winterize 2,000 wind turbines. What if we just really winterize the natural gas supply. So if this does happen again, maybe the turbines go offline, but we keep all of our natural gas, we keep all of our coal because the state is diversified. That seems to be maybe a sensible choice. That I mean, I can't imagine it would cost more than winterizing all those turbines. I mean, that's be a huge expense. But yeah, and the other thing that I'm interested in your opinion on is why. So we've been putting some Facebook posts out on the Weather Guard Lightning Tech Facebook page, and it's fascinating. The comments people leave are completely unrelated. They don't even read the article. They'll just comment. They're like, "Oh yeah, look how well they work in Texas." You're like, maybe put some time in engineering them to withstand the winter. And there's a lot of fingers pointed at wind turbines in this situation, where it's just like people are looking for a moment just to say, aha, see, renewable energy doesn't work. But that really isn't the case. Why do you think there's so many people ready to lash out at renewable energy?
Well, it comes with the baggage of really the politics that really shouldn't be attached to it. But wind turbines and solar are attached to a political movement. And when you're in Texas, there's not a lot of there's a substantial part of the population that disagrees with the approach of that political movement. And when given the opportunity to push back, they will, right? Because I'll give you that example. So there's a hurricane. There's a hurricane and it hits Texas. Well, the news stories are global warming is going to increase the number of hurricanes, and we saw it from Al Gore. The number of hurricanes is going to increase substantially, and we're going to have all those cataclysmic damage. It's going to cost us trillions of dollars a year to compensate for all the increased global temperatures. And then when it doesn't happen, you get this kind of response, like, well, what the heck, right? You told me the world was going to end, and I had to prepare my house for more hurricanes and my life for more hurricanes, and they didn't happen. And you're also the same proponent of wind and solar. Well, what the heck's going on, right? Who do I believe? Because do I believe my lying eyes? Is that what it just becomes this really politically charged environment where it doesn't need to be that way. There are places and times for wind turbines. There's places and times for solar. There's places and times for nuclear. But if we tie it to the world is ending, you're going to get this sort of vocal response. And I think that's sort of a natural outcome into the sort of the political environment that has been created for us, in a sense, by a lot of the media, which is, in order to get a headline, you need to get clicks. How do you get clicks? You get clicks by declaring crazy stuff's going to happen and can't really back it up. So it leads to a society that just becomes polarized. I think everybody needs to take a little bit of a step back and say, look, West Texas, for the most part, has been putting up wind turbines for a number of years. They're a benefit to Texas. It makes Texas independent of the United States in terms of power and energy usage, unlike my state, which is not. We depend on Canada a lot for our energy sources. And if Texas wants to remain energy independent, they're going to have to play in all the fields: solar, wind, natural gas. They probably still have some coal factories up. They're going to have nuclear sites up too. All those things are going to make it possible for Texas to be energy independent. If they're having a quote-unquote black swan event, that doesn't mean you trash the whole system. It just means you need to take another harder look at it and see where you may need to make improvements. But I sure as heck don't think that there's any financial or financials approach that would say, get rid of wind turbines. I think they are just part of the bigger scheme of energy variability and providing energy via various sources that helps the state of Texas. Why not? Why not do it that way? But where are you going to see that? Where are you going to see that conversation pop up anywhere?
Yeah. Yeah, it's really strange. I mean, Dan Crenshaw, who at times has some really intelligent thoughts, posted a really long thread on Twitter saying this is the truth about what happened in Texas. And he just says basically, wind froze and couldn't help us when we needed it. But the gas, the gas plants, they were still online, but the pipes froze, therefore it's not natural gas's fault. It's like, well, the wind turbines wouldn't have frozen either if people had, planned for a once in a century storm which he sort of gives. He says Texas infrastructure isn't designed for once in a century freezes. Which, okay, if you're going to give that pass to, like, why do you not give that pass to wind when you give that pass to gas? It just like they just want to take their sides, and it's like, look, everything failed. You know, all of it failed. But
right, and it doesn't help the citizens of Texas.
No, it doesn't help
to
anybody.
do that. And I saw the Dan Crenshaw Twitter feed and read through some of those points. I think part of that is just a natural reaction, like this sucks. I think that's what was just a frustration. Like, we're losing power. A lot of people are losing power. It's going to cause a lot of hurt to a lot of families that I know, and that's not cool with me. I don't like, but it's too early to tell as to what the correction would be anyway, and to lay blame that early is crazy. If you want to go look at what the real consequences was and where the failure points were, awesome. Do it and come back with something that's helpful to the people of Texas. And I think Crenshaw would be one of those people that actually would do that. I think he's going to be part of that mix to go help fix this thing if they're going to make any changes. But I do think we have created this polarization because there's one political party that is pretty much in the push for renewable energy, green energy, with the caveat, if we don't do it, the world's going to end.
Yeah.
And there's going to be a disagreement with that, naturally.
Yeah, well, in his conclusion, in his long thread, which was on February 16th, he ends it with, this raises the obvious question: can we ever rely on renewables to power the grid during extreme weather? The answer is clearly yes. I mean, they operate in really brutal conditions. But he says, no, you need gas or nuclear. So he just completely just chooses his own conclusion. Like, that's patently not true.
Yeah.
So it's like, okay, that's and with him being an intelligent guy, clearly, I've heard him on the Rogan podcast a couple of times. He's just choosing to overlook the fact that wind turbines can operate completely fine in any weather condition, pretty much. They just didn't this time. And so he says, because they didn't this time, therefore they never can. The fact is, can we ever rely on them is just patently untrue. So it's just, I don't know. Yeah. Finger pointing is finger pointing, I suppose. But
yeah, we all fall into that same trap, right? That sort of first gut reaction and not really thinking through what's actually happened. And that's what the problem with Twitter is. You can post those emotions to the world, and if you had another 15 minutes to think about it, you would have posted something different.
Yeah, it's a lot of
that's the world we live in.
A lot of confirmation bias. People speaking to their base, and
sure,
and again, I'm not a Democrat. I'm not a Republican, so I really don't have a horse in the race. But you definitely see people like, wind power is, without fault. That's not true either. That is intermittent, right? That's the biggest con of it. When the wind doesn't blow, they don't produce. Right. Like that's a thing. Right. It certainly is. But they are, a nuisance to some people, and we'll chat about that on an upcoming episode more as well. But there's pros and cons to all of it. But it doesn't seem like going back to fossil fuels in 2021 is really like the new path up the mountain to a better planet and better economy. That's just not it.
Yeah, it may not be, right? It may not be. It may be, and we're still trying. I think we're still trying to figure a lot of that out. I do see. I listen, and you do too. We listen to a lot of podcasts in the sort of the green energy sector, and a lot of those podcasts do not talk about anything in the technology field at all. They're talking about policy, and the policy goes like this: the world's going to end in 9 years, therefore X. Well, okay. We don't have a lot of agreement about the 9-year thing. That's an assumption, one. And two, your X has a cost associated with it. And if you're going to devote those kind of resources to that one particular outcome, if that's the only thing that matters, and that's what you're saying when you say the world's going to end in 9 years, is that you're saying, well, there's only this solution or we all die, then you're not really taking a real hard look at what all the options are, nor are you looking at what the consequences of making that decision are. That's troubling. I think that's really troubling. And I've listened to a couple of podcasts just recently where that has been the assumption. Like, well, we can only do X. Well, we can't only do X, because who knows how many people that's going to leave hungry, starving, and dying on the streets, right? Because those are the real consequences to making global changes to power distribution systems, is that people will die, right? Or people will starve, or people won't get educated, and all the things that will happen. And that weighing those costs and benefits needs to happen. We need to take away the world's going to explode in 10-year discussion and get to reality. And we're starting to see a little bit more of that from like an Elon Musk. We're starting to see more of that from a Bill Gates. Electrification allows, in a lot of cases, kids to go to school, right? That allows them to have fresh water so they don't die when they're infants from diseases that they shouldn't be having. Those are those consequences to energy policies that we really need to get out on the table. And I hate this. I really despise this. We need to have an honest conversation bull crap that goes on. Look, there are a lot of smart people out there that have looked at a lot of the cost benefits of this, and we need to evaluate which ones come first. And I think when we've looked at which pain points in terms of humanity come first, carbon dioxide emissions doesn't typically reach top 10. Now, it doesn't say it's not an important issue. That's not something we're not going to address. I think we are going to address it, and it is an important issue, and we need to do that. But we also need to balance it with other things, and that's where the engineering part and sort of the financial aspect of it and that need to come into it. And we haven't gotten to that point yet. It's still too political.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install Strike Tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.